All right, so we have this example where we're going to look at the binomial distribution. And for this one, I'm going to solve a problem without using a calculator, or at least set it up. A box contains 3 red marbles and 7 blue marbles. From the box, n equals 4 marbles are drawn with replacement. So each time when you take the marble out, you put the marble back in. What is the probability of drawing exactly k equals 1 red marble? Okay, so if you look at this situation, the possible ways to draw 1 red marble is, well, what? You could get a red and a blue and a blue and a blue. If the first one could be a red, but then the second one could be the red and the rest are blue. Or the third one's red and the rest are blue. Or the first 3 are red and the first 3 are blue and the last one's red. Those are the possible ways. So if I'm trying to find the probability that x, which is the number of reds, equals 1, this is the probability either getting red, blue, 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 red. All right, so you write it down. When I say it, it just sounds crazy. But it's, as you see, we have 4 drawings, and we're saying the first one should be red, or the second, or the third, or the fourth. The other ones are all blue. Now, these are 3 different events that can happen, and they're disjoint. And so what you can do is you can use the sum rule and just add these together. However, one thing that's going to help us sort of save us here is that each of these has the same probability of occurring. So the probability of getting a red, if we draw a picture of this box, maybe we can see more easily. The probability of getting a red is 3 out of 10. But then that's the first drawing, but we follow it by 7/10 the probability of blue, 7/10 of blue, 7/10 of blue. The box doesn't change because we're replacing those marbles. Then we're going to get 7/10 for the blue, 3/10 for red, 7/10, 7/10. So if blue is 7/10 and red is 3/10. And then we go over here, 7/10, 7/10, 3/10, 7/10. And the thing is, every single one of these is the same. We're just reordering the numbers under multiplication, which by the commutative property give the same thing. So we actually have 4 times 3/10, 7/10 to the 3rd power. So maybe it's easier to enter this in the calculator if I use a decimal there. This number here is 4 choose 1. Why would that be? Because what's 4 choose 1? 4 choose 1 is the number of ways I can choose 1 out of 4. And what I'm choosing when I say 1 out of 4 in this case is I'm choosing where I'm going to put the red. there's 4 different places to put a red. I can put in the first, the second, or the third, or the fourth. So that's why it's 4, choose 1. For this problem, we can do this by hand because there's not that many places I can put the red. But say, instead of just 4 marbles, say I was choosing 10, and I was saying, what's the probability of getting 3 reds out of 10 drawings? Then we'd have to put 3 reds in position, and it would be a long thing to do by hand. So we want to have a formula, and this is this formula. This is the binomial coefficient. This number right here, that 4, choose 1. Why is it a coefficient? Because it's what we multiply this by. Why is it binomial? Binomial refers to that you have 2 choices, a red or not red. We're not talking about 3 different choices. Either get red or don't get red. That's why it's binomial. And this leads to a general formula that's a nice formula. And moreover, you can just use a TI-83 calculator, but it's good to have understanding of how this works.